In this lecture, we'll talk about perfectly competitive market. Now, if you think about how this market price determined, so far we have assumed that both the buyers and the sellers take the market price as given. This gives us the first fundamental theorem of welfare economics, which says that the market equilibrium is efficient. In other words, no one can gain without hurting someone else. We call this situation a Pareto optimal in economics. For the next few classes, we will focus on the assumption that the sellers take the market price as given. In the case that they do, it's the perfectly competitive market. In the cases that they don't, or it doesn't, it will be monopoly. What conditions are necessary for you to consider a market competitive? For a market to be competitive, if a seller raises its price, it should lose a lot of business to competitors. Otherwise, there's no competition to speak of. Sellers should be selling relatively similar products. Otherwise, they probably won't be in the same market in the first place. There should be many potential sellers and buyers. Now, the word potential is the key, since the sellers and the buyers might not currently be in the market. As long as there is potential competitors, a seller might not be willing to raise its price. So the perfect competition model imposes this condition in the most extreme case. It assumes that if a seller raises its price above the market price, it loses all business to competitors. If a seller lowers its price below the market price, it gains infinite business from competitors. Now, if you look at the demand resulting from such assumptions, what you get is a horizontal demand. Because the sellers get to sell as much as it wishes at the market price, nothing above, and infinite demand below. Now, this is clearly not a realistic assumption, since no market has infinite demand. Nevertheless, this is a simplifying assumption that lets us focus on the effect of competition. So in this case, sellers will only charge the market price. In other words, they are price taking. The perfect competition model imposes this condition in the most extreme case. Sellers and buyers are price taking. Sellers sell identical products, completely identical. There are infinitely many potential sellers with free entry and exit from the market. And for simplicity, we usually also assume sellers have identical cost functions, although this is not strictly necessary. Once again, these assumptions are very extreme, since there isn't possible to have infinitely many potential sellers in any market. And sellers do not sell completely identical products because there's usually a difference in location and surface. Nevertheless, these assumptions allow us to focus on the essential idea, competition. So it's an approximation to a situation where there are many very small sellers. One example I can think of is some popular products on Taobao or eBay, where there are many sellers selling very similar items. The model has a short run and a long run component. Short run has dual implications in the model in the following way. First, sellers face short run cost functions, and second, number of sellers is fixed, with no entry or exit possible. The first implication is usually not important, and we very often use the same functions for short run and long run. Number two is the important one. With the number of sellers fixed, solving the model involves finding the market supply curve, which is the number of sellers times individual supply. This is possible because we know the number of sellers and we assumed that they all have the same individual supply curve. Second, calculate the short-run market equilibrium by equating market demand to market supply. Notice that this is what we have been doing all along for demand and supply. So in other words, one can say that we have always been considering the case of short run. Let's take a look at this example. Demand for ice cream cones is given by Q equals to 126 minus P. The short run average cost is 20 over Q plus 6 plus 5Q, and the short run marginal cost is 6 plus 10Q. There are 5 sellers in the market at the moment. Assumes that the seller cannot shut down. Now first, find the short run market equilibrium price and quantity. To do that, we start with marginal cost. Marginal cost equals to 6 plus 10Q. We know that under competition, the most sellers can charge is 6 plus 10Q, which is marginal cost. So we replace MC with P. P equals to 6 plus 10Q. Rearranging gives us the individual supply, QS equals to P minus 6 over 10. Now let's find the market supply. With 5 sellers, the market supply is P minus 6 over 2. Equating demand equals supply gives us the market equilibrium. What we have is 126 minus P equals P minus 6 over 2. So P equals 86. And Q equals to 126 minus P equals to 40. Second, we would like to know how much profit or loss is each seller making. To know that, we would need to know how many units each seller is in fact selling in equilibrium. Since the market equilibrium quantity is 40, and there are 5 sellers, each seller is selling 8 units. Profit is price minus average cost times quantity. So that's 86 minus bracket 20 over 8 plus 6 plus 5 times 8 close bracket times 8, which is 300. Now you might notice that sellers are in fact making a positive profit. How is that possible under competition? In the short run, the number of sellers is fixed. The sellers compete to offer the lowest price, but none of them will sell a product at a loss, meaning they will not set a price below marginal cost. So they will stop offering a lower price when price equals marginal cost. For that reason, they can still be making a profit because marginal cost could be above average total cost. Now let's consider the case of McDonald's and Yoshinoya. Notice that they have the exact same price for some of their most popular items. Is that a coincidence? Turns out that's an implication of the long-run competitive market, because in the long run, new sellers can enter the market. Now let's consider how this works. Imagine there's an existing seller, number 1, charging a price of P1. Because P1 is relatively high, it intersects with marginal cost at a place where marginal cost is higher than average total cost. As a result, the seller is making quite a profit. Now, a competitor, number 2, looking at the situation, it realized that it can charge a slightly lower price P2, undercutting seller number 1 and taking the market for itself. By doing that, seller 2 earns a profit, though not as much as seller 1 because the price is lower. But it doesn't have to stop here. Another seller, number 3, could very well enter and charge an even lower price and earning an even lower profit. And this process continues until the price reaches the point where marginal cost intersects with average total cost. Now notice this is the point where the average total cost is lowest and there is no undercutting possible. And as a result, sellers are earning no profit. So competition from new sellers drive price down to the lowest average cost. Long run also has two implications in the perfect competition model. First, there is long run cost functions, and second, the number of sellers is variable, so there is free entry and exit. For simplicity, sometimes we just assume that the long run and short run costs are the same, so point 1 is not important. Point 2 is the important one though. As potential sellers can enter, competition from new sellers drives price down to the lowest average cost, as previously demonstrated. In the long run, at what level of output is average cost the lowest? For U-shaped average cost curve, we already know that's the point where average cost equals marginal cost. But what if the average cost curve is not U-shaped? Consider the case when average cost is increasing, like this one. If you look at the diagram, you should realize that if sellers are undercutting each other, eventually they will all be producing a very tiny amount because that's the point when average cost is lowest. But because they are all producing so little, it will take a lot of them to fulfill market demand. In fact, it will take infinite number of them all producing tiny quantities, zero quantity, to fulfill market demand. Now this is a theoretical exercise. It does not mean to mean that in reality there will be infinite sellers. What about decreasing average cost? Like this one. Once again, if you look at the diagram, you should realize that the bigger a particular seller is, the cheaper its product will be. So in this market, one seller should eventually dominate the market. To solve the long-run component of the model, first calculate the efficient scale for an individual seller. This is found by equating long-run average cost to long-run marginal cost. But if you cannot find a solution with a positive value, it means that the average cost is not U-shaped in the long run. In this case, plot a few points of the average cost function to see how it is shaped. Or if you know calculus, you can just take the derivative with respect to quantity. If average cost is always increasing, the efficient scale is 0, which means there will be infinite number of sellers. If average cost is instead always decreasing, the efficient scale is infinite, meaning there will just be one seller. We have already discussed why these three cases are so. 2. Calculate the long-run market supply. If you find a positive efficient scale in the previous step, the market supply is a horizontal line with price equals marginal cost at the efficient scale, which is also the point where average cost is lowest. This is the case because sellers compete to offer the lowest possible price, which is at lowest possible average cost. Now, the supply also equals to the number of sellers times the quantity they supply, which is the efficient scale. Now, how do we reconcile this with a horizontal line, as we said just now? This is possible because we do not yet know what the number of sellers is. In the long run, the number of sellers adjusts to meet demand, so which is why the supply curve is a horizontal line. If you find that there will be an infinite number of sellers, the market supply is also a horizontal line with price equals to marginal cost at a quantity of 0. Remember, each seller is selling a tiny quantity in this case, so the price they charge is the marginal cost at Q equals 0. The number of sellers will be infinite. If you find that there will only be one seller, market supply is the marginal cost of that seller. Third, calculate the long-run market equilibrium. This is done by equating market demand to market supply. But since the supply curve is essentially a single price, we can solve for the equilibrium quantity by combining demand and supply. So quantity at market equilibrium equals to demand at the price given by the long-run supply. If there will be more than one seller, we can solve for the number of sellers using the fact that the quantity at market equilibrium equals to the quantity supply. So the number of sellers equals to the market equilibrium quantity divided by efficient scale, as suggested by the formula we had in the last slide. Now let's look back at an example. First, find the efficient scale of an individual seller and the corresponding average cost. Now average cost equals marginal cost give us the efficient scale. So 20 over Q plus 6 plus 5Q equals to 6 plus 10Q. So Q equals to 2. To achieve the lowest possible cost, each seller has to be producing 2 units. The average cost in this case is $26. 2. Find the long-run market equilibrium price and quantity. Price equals to the lowest possible average cost. So this is 26. The long-run equilibrium quantity is given by what demand is at $26, which is 100. The number of sellers adjusts to meet demand. So the number of sellers equals to the long-run equilibrium quantity divided by efficient scale, which is how many units each seller is producing. So to meet a demand of 100, when each seller is producing 2 units, you need 50 sellers. Notice this is a lot more sellers than in the short-run equilibrium we had just now. 4. Now to make the problem more complex, I'm going to add in a twist. Suppose short-run marginal cost when deviating from a long-run output is 6 plus 10Q plus 2 times bracket Q minus Q long run, close bracket. Now this is purely to add in some complexity. write down the short-run marginal cost function for the long-run equilibrium we just found. So this is simply 6 plus 10q plus 2 times bracket q minus 2 close bracket, which simplifies to 2 plus 12q. 5. Suppose demand surged to q equals to 150 minus p. Find the short-run equilibrium and the quantity produced by each firm. Now the new marginal cost is 2 plus 12q. Remember, sellers compete to offer the lowest possible price, so they price at marginal cost, so price equals to 2 plus 12q. Rearranging gives us the short-run individual supply, which is p minus 2 over 12. Market supply is given by the number of sellers times individual supply. In the previous long-run equilibrium, we have 50 sellers. So multiplied by the individual supply, we have 25 times bracket p minus 2 close bracket over 6. Market equilibrium is determined by demand equals supply. So you have 150 minus p equals to 25 times bracket p minus 2 close bracket over 6. Solving gives us price equals to $30.64 and quantity equals to 119.36. Notice that both the price and quantity has gone up from before. This is not surprising because demand is now higher. Finally, let's calculate the new long-run equilibrium. If you notice, nothing has really changed. Average cost and marginal cost stayed the same in the long run. So the efficient scale is still 2, and the average cost at the lowest possible point is still 26. This means price is still 26. However, because demand has gone up, the equilibrium quantity is also higher at 124. The number of sellers gone up to adjust for this. So the number of sellers equals to 124 divided by 2 equals to 62. Now notice that what's happening here is that the number of sellers increase, meaning that new sellers entered the market because demand is now higher. This pushes price back to the lowest possible point, which is $26.